Hey guys, this is an examples video of using derivative rules, and in this video I'm only going to use the product and quotient rules. So what we're going to do is we're going to take the derivative of these four functions, and so I know that a lot of these could be simplified or multiplied or whatever, but remember the whole point of this is to be using just the product and quotient rules, so we're not going to simplify any farther. Now, in case you forgot, here's the product rule, and you can pause the video if you need to write that down. And here's the quotient rule. So as you can see, we're going to have to identify what stands in the f of x and g of x place for each one of these. So starting with the first one, I've got 3x squared minus 6x times 2x plus 1. So for this one, so this is going to be, this first part is my f of x, and this second part is my g of x. So if I want to take the derivative of this, so remember you're going to take the derivative of the first function, leave the second function alone, then leave the first function alone, and then take the derivative of the second function. So what that means then is I have to take the derivative of this part right here. So the derivative of 3x squared minus 6x is going to be 6x minus 6, and I do nothing to the second part of this. Now I move on and I leave the first part of this function alone, and then I take the derivative of 2x plus 1, which is just 2. Now, from here, you could actually go through and multiply everything out, or, it just depends on what the final answer needs to be. So I'm actually just going to leave it here because, you could just multiply from here if you wanted to. Okay, so for B here, so this one's going to use the quotient rule, or that's what we have to use. Now, one thing I want to point out, you could have totally made this like 10 times easier if you just simplified. So the point of this exercise is to actually just get some practice using the quotient rule, but like probably normally I would just like actually make the cancellation of x to the 7th and x to the 5th. But okay, whatever. So this is going to be my f of x, this is going to be my g of x, and I'm going to show you kind of two different ways to do this, I guess. So first we're going to just straight up use the quotient rule. So there it is. Pause the video if you need to write it down. Okay, so I need to start out by taking the derivative of the top function. So that's going to be 21x to the 6, and then I leave the bottom function alone. Okay, and then I leave the top function alone like this, and then I can multiply that by the derivative of the bottom function, which is 10x to the 4th. And then all of this is over 10, oops, what am I doing? What am I doing? Okay, 2x to the 5th, and then I need to square this. Okay, so there are the pieces to this. So now what I want to do is I actually want to work this all the way out. So we're going to do a little bit of a lift here with the algebra. So let's see, if I multiply these two pieces together, this is going to be 42x to the 11th. And then this part here, so this is going to be, let's see, 30x to the 11th. Interesting. X to the 11th. All of this over, so this thing squared, this is 4x to the 10th. Okay, so now we want to work this out as far as possible. So let's see if I can make enough room here. So 42 minus 30, let's see, that's 12x to the 11th over 4x to the 10th. Okay, so now let's just simplify that all the way. So this is just coming out to 3x. Interesting. All right, so I've got the derivative, so let me make some space. And now I'm going to put my skeptical pants on, and I'm going to say, that seems awfully simple. So what I want to do is I want to go back to my g of x, but I want to write this out now in a simplified form. So this would be, if I wanted to just go ahead and subtract the exponents, this would be 3/2 x squared. So if I take the derivative of that, what is that? That's 3/2 times 2x, which is just going to come out to 3x. So it totally works. So usually the quotient rule was kind of overkill in this case, but this is a really nice way just to double check yourself. Like making little functions like this for yourself is a good way to help yourself figure out if you've really got it, and also help you kind of sort out some of the algebra. Okay, so moving on to this next one. So like I said, we're not actually looking to distribute here. We want to keep this as is, and we want to just use the product rule. So this first part is going to be my f of x, and this second part is going to be my g of x. So the structure of my derivatives, so just to remind you, so it's going to be f prime of x times g prime of x plus f of x times g prime of x. Now, as you're learning the derivative rules, I'd highly recommend that you just keep writing those rules out over and over until you really get it in your system. And just one other note before we start this. So for this square root of x, remember that's x to the 1/2, so those two are one and the same, so that's going to help us take the derivative. Okay, so taking the derivative of this first part, so I've got the derivative of 5 times the square root of x. This will be 5 times 1/2 x to the negative 1/2 plus, and now the derivative of 3x to the 4/5. I'll take 3 times 4/5 x to the negative 1/5. Okay, so that was just the derivative of the first part, and then I leave the second part alone. Okay, so there's the first part of this. And now I leave the first part of this function as is, like this, and I take the derivative of this 7e to the x. Well, the derivative of e to the x is just e to the x, so this is just going to stay 7e to the x. And so once again, there's a lot of other simplifying that you could do here. So if I just wanted to at least multiply the constants together, I'd have 5 over 2 x to the negative 1/2 plus 12 over 5 x to the negative 1/5, and then 7e to the x. And then continuing on from there, I'd have 5 times the square root of x plus 3x to the 4/5, and then 7e to the x. And you could always factor out 7e to the x if you wanted to. There's a lot of different ways you could simplify this. You could distribute it. There's several different ways that you could actually do this. So I'll just leave this here and say that we got the major structure of the derivative. And from here, it would just be a matter of simplifying. And now for this super fun last one. So now I wanted to have an example where we use both the product rule and the quotient rule all in one example. So I know our lives would be a lot easier if we could actually just kind of multiply everything together, but we're not trying to make our lives easier, we're trying to practice. So in this case, what we're going to do is first just remember that this top part, this is my f of x, this bottom part, the whole thing is my g of x. So if I think about the structure of this derivative, so it's f prime of x times g of x minus f of x times g prime of x, and then all of that divided by g squared of x. Okay, so we're going to use this as kind of our guiding structure for this, and then as we're taking these derivatives, that's where we're going to invoke the product rule, and I'm not going to bring that in here just for the sake of saving space. So let's get this party started. I've got, let's see, I need to change my color here. This is y prime. So first I need to take f prime of x. So think about taking f prime of this. This means that I have to use the product rule to take the derivative of the top. So I highly recommend actually that you try to fill this top part out as best you can. And so we'll just start there. So just take the derivative of this top piece. So I'm going to do this part entirely in pink, okay? So starting with the derivative of this piece here, so I first have to take the derivative of the square root of x minus 1. So the derivative of the square root of x minus 1, this is 1/2 x to the negative 1/2. There's that derivative. And then I multiply that by just the other part, right? I haven't taken any derivatives yet. And then I add to that, so then I leave the first part of this alone. And then I have to take the derivative of x plus 1, which is thankfully just 1. Okay, so this part here, this is my f prime of x, and now I have to multiply that by g of x, which is this entire bottom part. So this is going to be the square root of x plus 1 and then x plus 2. So that's just the first part of this derivative. Okay, so moving on, now I'm going to use this gold color to work on the next part of this. So we'll do minus, and let's see. So for this case, I want to leave my f of x alone. So this whole top part here, I can just write that down. So this is going to be the square root of x minus 1 and x plus 1. And now I need to work on taking the derivative of g prime of x, which is this whole thing. So now I have to use the product rule. So first I take the derivative of this part right here. So the derivative of the square root of x plus 1 is just going to be 1/2 x to the negative 1/2 once again. And then I multiply that by x plus 2. And so that's the first part. Now I have to take the derivative of x plus 2 and multiply it by the square root of x plus 1. So let's see, I'll see if I can squeeze all that in here. So square root of x plus 1. So the derivative of x plus 2 is just 1 again. So there's all that. So all of this is huge, I know, but all of this is the numerator. And so I'm going to put like these blue brackets around with this division sign to then also note here that my denominator is going to be the square root of x plus 1 squared and then x plus 2 squared. So that's the whole denominator. And from here, so now you can continue to simplify. So once again, I'm just making this video to help you guys make sure that you're kind of getting the structure of these derivatives right, because from here on out it's kind of algebra. But if anybody wants to actually see more examples where I kind of simplify more stuff out or stuff with more algebra, just let me know and I will happily make more videos. So otherwise, that covers it for this particular example video. Hopefully that was helpful to you guys. I'll see you next time.